Hello. Yesterday, I walked through about this problem subsets, and today, one more time, rethinking, I revisiting of this problem. So, one thing in the previous video, we implemented this without passing subset. Without passing subset argument as an argument of this DFS function, but we can also include it passing as an argument. For example, like this. We don't define subset out of the DFS. We pass the subset as an argument. In this case, we pass DFS. We pass subset to the DFS function and subset DFS function, and last is empty subset. This is same, but passing as an argument, the function becomes more self-contained and explicit. It clearly defines what states the DFS is currently operating on. And it keeps the function pure in the sense that it doesn't rely on variables hidden in the outer loop. Outer scope. How about using outer scope variable? Define subset in the outer scope makes the function signature cleaner and more concise. We don't have to pass the same reference over and over again. In this case, the DFS function modifies a shared states directory. Since Python lists are mutable, it works perfectly fine as long as we manage the append and pop operations correctly. It's a matter of preference. Both approaches have the same time and space complexity because they both operate on the same list reference in memory. But my preference is right one. Because in the real, if we work on the office and we're a software engineer, this is maybe this is global variables. So we can change this value anywhere, but it is not reliable. So I like defining as an argument. Okay, next point is earlier we mentioned the space complexity is O big O n times 2 to the power of n. But if we don't include the output list, this output list, it's big O. It's big O because recursive depth is n at most. So recursive depth is this decision-making tree's height. If we include the output list has 2 to the power of n number of subset. And the average size of subset is n over 2, but we can ignore this constant. So the result is n times 2 to the power of n is space complexity. Okay, that's it. Thank you for watching.